In this section of Chapter 5, we're going to put our stereoisomer nomenclature into our double bonds. So if we have di-substituted double bonds, we can use that cis-trans designation. And the cis-trans designation is going to go in front of the molecule, just like we saw the R and S designations going in front of the entire molecule, followed by a dash. So let's look at an example here. We have one double bond within our structure, and it has the hydrogens within our double bond on opposite sides. So this has a trans designation. So we would label this as trans 5-chloro or 5-methyl hex 2-ene. So once again, we would have that trans because it is only di-substituted and the hydrogens are on opposite side. We have a methyl group in position number 5, and then we have a hex 2-ene. So trans 5-methyl hex 2-ene. If we have tri and tetra substituted double bonds, or if we have multiple double bonds within our structure, or if the double bonds are in a ring, we're going to use E and Z designations instead of cis and trans designations. So the Z designation tells us that the higher priorities are on the same side of the double bond. And it comes from the German word for same, zusammen. If we have the E designation, E tells us that the higher priorities are on opposite sides. And again, it comes from the German word for opposite, antigen. So let's look at our rules for assigning E and Z around our double bonds. Remember, we're going to use these if we have tri and tetra substituted double bonds within a ring, or also multiple double bonds within our structure. So the first thing is we're going to focus on the double bond, and we're going to look at each carbon within the double bond by itself. So I'll look at carbon atom on the right of the double bond, and then I might look at the carbon atom on the left of the double bond. And I'm going to rank each substituent on the individual carbon atoms according to their priority rules. So this time I'm only going to be using priority number 1 and priority number 2, since we're only looking at individual carbon atoms, and they only have 2 groups associated with them. Then I am going to look at both the carbon's atoms within the double bond together. And if the 2 high priorities are on the same side, so 1 and 1 on the same side of the double bond, it has a Z designation. If the 2 high priorities are on opposite sides, so the 1 is on one side for one carbon, it is on the opposite side for the other carbon, we will use the E designation to tell you that they are on opposite sides. So let's look at a couple of examples. Again, I recommend trying these yourself with the E and Z designation, and then come back and check your work. So for example number 1, we only have one double bond. So I'm going to look at the double bond on the right first, the one with chlorine, and assign my priorities. So chlorine will get priority number 1, the carbon chain will get priority number 2. I'm then going to look at the carbon atom with the bromine, and the bromine will get priority number 1, and the carbon chain will get priority number 2. So when I look at this, the 2 1s are on opposite sides, so this has an E designation associated with it. So I would name this as E 5-bromo 4-chloro 7,7-dimethyl and then undec 4-ene. And remember, it should all be one word. I'm sorry I ran out of space, but remember, they should all be one word for us. So again, that E designation went out in the front of the entire name, followed by a dash sign. For the ring, if we look at the ring and you assign priorities, the fluorines on each carbon atom would get priority number 1. The carbons would each get priority number 2. So this has a Z designation associated with it. So we would name this as Z 1,2-difluoro cyclohexene. Again, the 1 and 2 for the ene does not need to be listed because in a ring, the double bond needs to be between carbon atoms 1 and 2. For our last one, we have 2 double bonds in them, so I have to use E and Z designation for both of them, even though one of them only is di-substituted. So do keep that in mind. Since we have multiple double bonds, I have to use E and Z designation for both of them. So for the first one in our chain that we would be looking at, there is a hydrogen here. So hydrogen gets priority number 2, the methyl group priority number 1. The long chain would get priority number 1, the methyl group would get priority number 2. So if we look at this one, our 1s are on opposite side, so this would be an E designation. If I look at the other one in our structure, it has 2 hydrogens on it. Both of those hydrogens get priority number 2, which means the carbons all get priority number 1. So if we look at this one, the 2 1s are on the same side, so this is a Z designation. So this full name would be 2E, comma 6Z, and again I would have to use locants because I have 2 of them. So I have to tell you which double bond is which. So it is a 2E and a 6Z. And then 3-methyl, octa, 2,6-diene. So once again with this, you'll notice that we have used those locants twice again. Once to tell you about the stereochemistry, 2E, 6Z, and then once to tell you about the actual substituents, the functionality, in this case, the double bond, so 2,6-diene.